welcome back to part 2. So this is a continuation of what we started in part 1 with functions. A review for the last video that we did, the last lesson we did was a little review on the graphing aspect, how to identify a function using graph, and that's using a vertical line test to determine if it is a graph or if it's not a graph. For today, another way to identify if it's a function or not is through the function family. So 1, you're going to identify by equations, or 2, identify by patterns in a table. Per usual, we're going to read a little bit, then we're going to do some examples together, then jump into apply that information that we learned and jump onto the Regents question. So the primary function families are linear, exponential, and quadratic. They are distinguished by how their output, y, changes as the input increases. So for the first one, identify by equations. You can determine the family by looking for specific structures in the equation. So if you're given an equation as y equal mx plus b, then you know that's a linear function. If you're given an equation with y equal a times b and the little x is in the exponent area, then you know that's an exponential function. And if your equation is y equal ax squared plus bx plus c, then you know it's a quadratic function. Right. We go move on to identify by patterns in tables. If given a table of values where x increases by a constant amount, look at the y value. So you're always, if you're given a table, you're always focusing on your y value column. So if you're using a table, you always want to find a constant number that's causing your y value to change. Always trying to find that constant number. If it is a linear function, you're going to add or subtract the same number each time to get the new value of y. If it's an exponential function, you already found your constant, you're then going to multiply or divide that constant number each time to get the new value. For quadratic function now, constant second differences. The first difference change, but the difference between those differences is constant. That is so confusing. But we're going to do some examples so you guys can see. The tables below, we realize that we're always focusing on our x column, always, right? Always, if you're given a table and they say, what is this function? You always focus on your y values. The next thing you're going to do is, you're going to ask yourself, are the numbers in the y increasing or decreasing? Or are they fluctuating? So here we realize that we start with a positive, then we move down to a negative, which would mean that this is decreasing. On this table, we realize that it started with a positive, then it went to a negative, positive, negative, positive. It's somewhat fluctuating, but we can see a pattern that it is increasing. Then for this one, we realize that -1, -2, then back to -1, +2, +7. So we can somewhat say that this is up and down, but it's mostly increasing because we realize that the last two numbers are positives. Okay, so with that information, we identify if they're increasing or decreasing. One key information that I want to highlight as well, when we're adding, the numbers are always getting bigger. When we're subtracting, the numbers get smaller. When you're multiplying, the numbers get bigger. And when you're dividing, your numbers get small. It's key information to use. Okay. So, we know that our numbers are decreasing. Either or sign will be subtraction or division. To move from 11 to 8, we know we're going down by 3s. To move from 8 to 5, can we think of a number to divide to get the next term? Not really. We would somewhat get a whole a decimal instead of a whole number. But for this, we realize that we're decreasing by 3s, and we have to subtract by 3 to get the new value of y. So we know our constant number is 3, and our sign is subtraction. We know we have to subtract. So if we go back to our notes, it says that we found a constant first, just 3. And if we have to add or subtract, it's a linear. So in this case, if we didn't have this information and we did the work, we would know that it's a linear function. Okay, on to the second table. Always focus on our y. We already observed and realized that the numbers seem to be increasing. So if we're increasing, it has to be plus or multiplication. We have to figure out the pattern. What is the constant number that we're increasing by? So we know we multiply any number by 1, we're going to get that number. So if we realize the next number in line is a -2, we're going to say 1 times -2 gives us -2. Then we're going to say our answer, -2 times -2 gives us +4. Again, our answer, we realize, is a 4 as well. 4 times -2 gives us -8. So we realize on the side that we have -2, 4, -8, and those are what's inside of our y column. So we identify, use a different color. So we identify that our constant number is -2, and the sign that we are using is multiplication. So constant, -2, sign, multiplication. If we don't remember, we go back to our notes, and it says you multiply or divide by the same number each time. So we know this is an exponential function. I would suggest for the next table, for the quadratic, it's a little bit more confusing to figure out. So I would suggest, if you realize there is no real definite pattern, the numbers fluctuate, then you know that it's a quadratic formula, a function. So we started with -1, we moved to -2, then we were back to -1, then +2, then +7. There is a way that you can find what the constant number is, but as I said before, it's a little bit more complicated. If you're doing the Regents exam, you want to be able to look on, find a pattern, and move along to your other questions, especially if you're not given time and a half or double time. So if you see there is a fluctuation in your numbers for your y, then you know it's a quadratic function. Okay. If you need to take a minute, pause, review what we just did, you guys definitely can. If you think you're good to go, we will move on to the next part. So the other part of this is a guided practice. So So we're not going to do the independent practice because you guys do not have the copy of this, but we're going to do the guided practice. Then we're going to look at the Regents questions. So the first guided practice says, input X, output Y. Always focus on your Y column. And then it says pattern observed. So I would implore you, it is your exam. If you need to mark up your paper, not in a way that the person that is grading it isn't able to understand, but mark it up in a way that you're able to understand and you're able to write down information that will help you to solve the question. You're free to do that. So we're going to look for the pattern. We know that we started from 5, and if we're going down to 14, we know we are increasing. So to move from 5 to 14, if we go back to our notes, we know that to get bigger, we're either going to add or multiply to get a bigger number. So we know that we're either going to add or multiply if we're increasing. Right. So to move from 5 to 8, we're going to say, what can I multiply to get 8 by 5? There's no possible number we can multiply, so we know that we probably have to add. What can I add to 5 to get 8? I would suggest 3 is the number you can add. Then we realize that we get 8. Then we say 8 plus what will give us 11? So we say 9, 10, 11, 3 again. So we realize that the constant seems to be 3. Let's try one more number. Say 11 plus what number will give me 14? 12, 13, 14, and that again is 3. So we know that our constant in this case is 3, and we did find a constant. And what sign we use is addition. So if our constant is 3, which we did find a pattern, and if our sign is a plus, then we know this whole table is a linear function. Right, table 2. Again, say that we didn't know it was exponential, right? And even if you know that it's exponential, how can you prove it? So we look at our pattern for our y. Realize we start from a small to a bigger number, so we know we're increasing. And again, we know that we have to add or multiply to get a bigger number. If we have to add or multiply, we're going to say 1 plus what will give me 3. We can say 1 plus 2. Okay. 1 plus 2 gives me 3. Let's think of multiplying. 1 times what? 3 will give me 3. Okay, so the first one works. Let's see. 3 times what will give me 9? And then 3 plus what would give me 9? So we know 3 times 3 will give me 9. 3 plus what? 4, 5, 6, 7, 8, 9, 10. Wait. 4, 5, 6, 7, 8, 9. 6. So 3 plus 6 is 9. Already we realize that this is broken. The constant is 2 and 3. There's no constant here. Over here we realize there's a uniform number here. So let's do one more. 9 times what gives us 27, and 9 plus what gives us 27. So we know 9 times 3 gives us 27. If you're not sure, right, of what gives you 27, 18 plus 9 gives us 27. Still, the numbers keep changing, so we know it could not be addition, it has to be multiplication. So we know our constant number is 3. That's the number that we're constantly going up by to get the new value of y. And our sign is multiplication. So if we're multiplying, that would be exponential function. So, review on that. If you're given a table, first thing, identify your y. Sometimes they will give you your y to be f of x, g of x, h of x, da 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 da. That's your y. Identify your y. You see what is happening. Is it increasing, decreasing? Okay, if you know that it's decreasing, then you know the signs would be subtraction or division. If you realize that the pattern is increasing, you know it will be plus or multiplication. Once you rule that out, then you know what steps to take. Then you find the pattern. What pattern do you see? What do I have to multiply or divide by to get the new number? You should ask yourself. Good. And then you find the constant and what sign did you use. Once you figure that out, then you know that it is either exponential or linear or quadratic. Okay. Then the other part says identify the type and the pattern. We're not going to identify the pattern, but we're going to identify the type. So it says y equal 4x, focus, good. Y equal 4x minus 4. So I'm not going to flip over, but I'm going to get another paper. And I'm going to compare. Which one of these equations match my given practice question? If I need to rewrite the given question, then mark it up and say, okay, I remember that this one said this. Does it match? Absolutely not. The next one is x plus b. This looks like it matched. And then the last one was y equal ax squared plus bx plus c. Absolutely, this doesn't match this, and this doesn't match my blue one. So I know that my answer is a linear function. Right. The next one is y equal 3 times 2, and my little x is in the top. Now I remember that the little x being in the top would be exponential function. Beautiful. And the last one, I will say pause and try to figure out, what do you think this is? Do you think it's a linear, exponential, or a quadratic? Pause it, figure it out, and then come back to this video to see if you got it correct. Alright, so I would suggest rewriting it. We want to rewrite this in the correct form so we can see what function it is. This is in a fraction form. So we need to break the fraction, get it into a whole number. So we know this cancels. We're left with y equal 20 plus x. So 2 times 10 is 20. This x that's left, we bring it down. You can, I wouldn't suggest to leave it like this, but you can. But the final product would be y equal x plus 20. If you don't know what these are, this is your variable. So the letter is called your variable. The number. So if you are given something looking like this, let's do a little backtrack before. So let's do our previous question. The number before your letter, so whenever you have a number attached to your x, this is your coefficient. The letter is your variable. And then the number without any letter attached to it, that is called your constant. Now, if you remember in your math class, your teacher will always write or give you an equation with the variable first and then the constant last. This is how you always want to leave your answer. So we would rewrite this, put the variable first, then your constant will go last. Oops. That was a lot of information. But just so you know, because some of the questions they will ask you, what is your coefficient? Which we will do that example when you're doing polynomials. They will ask you, okay, what is the highest coefficient or something of that sort. But when we do the questions, you guys will realize and probably remember that I brought that up before. But the number that is before your x is called your coefficient. In this case, your coefficient would be an invisible one. So when you don't see a number in front of your x, that's an invisible one. But all in all, how this would be is y equal x plus 20. And we ask ourselves, which one of the functions does this look like? And we would say it looks like a linear function. And that is that for this activity. The other parts of this worksheet is just the independent practice where you would practice them on your own. But we are going to move on. So the Regents questions that I want us to try for this aspect of the lesson. So for this part, we're going to do with the Regents questions. We're going to do 3 Regents questions, and then that will be that. So the first one says, and this was August 2025, the tables below show the input and output value of 4 different functions. Which table represents a linear function? So we know for a linear function, there are only 2 possible signs, addition or subtraction. So in our tables, we are going to see which one of them we can subtract and which one we can add. Okay, wonderful. We know we always focus on our y column. So even though it says g of x, h of x, f of x, and j of x, these are your y values. You're then going to ask yourself, are my numbers increasing or are they decreasing? So if you look here, we see that we started with 6. The numbers are kind of like wobbly here because we have negatives, then we have a positive. But all in all, we know we're decreasing, and if we're decreasing, that will simply means that we are subtracting. On our notes, we remember saying that plus or multiplication makes a number bigger. Subtraction or division makes a number smaller. So in this case, we know we're only using 2 signs, addition or subtraction, because this is a linear. So we know that to make a number smaller, we have to subtract. Okay. If we are looking here again, we realize that our numbers are somewhat decreasing and then increasing. But we would say all in all, it's decreasing, so we're subtracting. Okay. Here is the same thing. We're moving from a bigger to a smaller number. And I say bigger to smaller because a number that is closer to 0 is considered bigger. A number far away from 0 is smaller. So we're decreasing, again we're subtracting. Then we look on g of x. We realize that we are in a negative, then we go into a positive, so that simply means that we are increasing, which we would be adding. Okay, let's do some calculation now. So on your calculator that you will be given, you're going to say 6 minus 1 is, the difference is 5. 1 minus 2, the difference is negative 1. Negative 2 minus negative 3 is 1. 1 minus negative 2 is 3, right? I was like, I don't know, I calculated something. Then negative 3 minus negative 2 is 1. What we notice here is that we don't have a consistent number. So we don't have a constant number, so we know this couldn't work. Off the bit, we see that there's not a consistent number. All right, move on to the second table. So 3 minus 2 is 1. 2 minus 1 is also 1. 1 minus 0 is also 1. 0 minus 1 is negative 1. And then 1 minus 2 is also negative 1. So we realized that we had a consistent number here, but the number started changing here. So we moved from a positive 1 down to a negative 1, which this would not be a choice. On to h of x. We know we're subtracting because we're decreasing. So negative 1 minus negative 2, that is positive 1. Negative 2 minus negative 4, that is 2. Negative 4 minus negative 8, that is 4. Negative 8 minus negative 16, that is 8. Right? So we realize we don't have a consistent number here. So this could not be our answer. No, we only have 4 answer choices. F, G, H, or J. We realize that we eliminated these 3 because of our calculation. And we're left with this one, which we could say is our answer, but let us double check. Okay, so we know we're increasing, number is getting bigger, so we're adding. So we're gonna say negative 11 plus what will give us 7. Let's try 2, we don't get that. Okay. Negative 11 plus 3, we get 8. Negative 11 plus 4, we get 7. Okay, let's try again. Plus 7 plus 4, we get negative 3. Plus 4, we get 1. So we realize that we keep increasing by 4, by 4, by 4, and by 4. We get the next term. Okay, so if we do get a consistent number, this is our constant, and our sign is a plus, we know our answer would be g of x. Okay, all right, we're gonna go on to question 14. So the next equation question says 4 quadratic functions are represented below. So we're given one in a vertex form. We're given in a graph. This is a parabola. We know a quadratic function creates a parabola. We're given the actual standard form, and we're given it in a table form. It says which function has the smallest minimum value. So we have to find out which one of these 4 will give us a smaller value. And we know that a number that is further away from 0 is the smallest number. Okay, so we know if we write this in the form, in the vertex form, this is a x minus h squared plus k. And if would write it in the vertex h, comma, k. H would be 3, comma, negative 7. Okay. Simple term. This would be your minimum. So your minimum is negative 7. For problem 2, so we realize that, so there are different ways that you can identify a minimum. It's either you call it a turning point, or your lowest value, or your vertex, right? So it either can be your turning point or your vertex, your minimum. Whichever one of these would still be considered or called your minimum. So we realize that we're decreasing. It stopped. It started making a turn. Where it starts to make the turn, that is called your vertex or minimum. And then we start to increase. This is connected to the value of y. So your minimum for this graph is negative 4. Right? Okay. The third one, we're going to see this because I'm going to show you how it is graphed in the graphing calculator. So we're going to go on to 4 and then come back to 3. So for 4, we realize that, of course, this is our y. Negative 1 is connected to this negative 1. Then we have negative 4 is connected to this negative 4. The one that doesn't have any connection, it doesn't have any pair or anybody, which would be negative 5. And that would be your minimum. So if you see that the numbers are repeating, you connect those. Draw a line, connect them. The one that you cannot connect, that is your minimum. Okay. For this, you're going to hit y equal. Clear these because I was doing another problem before. I'm going to say x square. And you get the square, press this half up like the top of a triangle, plus 6x plus 3. Hit graph. Forgot, this is the one that I need to reset. So if you get something looking like this, quit. That simply means that your calculator needs to be reset. Forgot, that's the one that I need to reset. So we do the same again. So x square 6x plus 3 graph. This is how your graph looks, right? You either can use the arrow here to point and tell you what point it is, or if you want to count to negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, realize that it's connected to negative 6. So the minimum for this is negative 6. So we have our minimum values. So one is negative 7, negative 4, negative 5, and negative 6. Again, if your value is far away from 0, so the furthest your number is from 0 on the negative axis, then that is your bigger number. So in this case, your biggest number is, your smallest number is negative 7, which is 1. Another thing that I needed to point out was that for parabola, it either can be written as, drawn as this, which this would be considered your maximum. And then your minimum would be the one at the bottom. Okay, all right. And then the last question that we're gonna work on is from January 2025, and that is question 13. So same idea. All right, off the bat, we know that we were only talking about 3 types of functions: linear, exponential, or quadratic. Off the bat, we know that number 4 would not work because we didn't talk about anything of absolute value. Good. Okay. So it's asking what function can be described in this table. We know this is our y, so we're always focusing on that. we observe, we realize that you probably can either add or multiply, so the numbers are not so out of line that you're not able to find a consistent number, so it could not be a quadratic function. Okay, so now that we eliminated 2, which I would always suggest that you eliminate at least 2 answers and be left with 2 possible answers. We observe in our y that our numbers are moving from decimals into whole numbers, meaning that we are increasing. So if we're increasing, we know that 2 signs make a number increase. It's either multiplication or addition. So they make numbers bigger. So we're going to figure out what number can I multiply to get the new value of y, or what number can I add to get the new value of y. Right. Here my graph. Oops. So my calculator is cleared. It's 0.0625 plus 1. I don't get that. Okay. 0.0625 plus 2. Nope. 0.0625. No matter what I do, I won't get the next value. So I know that it cannot be an addition, because it's going to give me the number that I'm adding by is going to come first. And that don't make sense. So let me try. 0.0625 times 2. I won't do by 1, because if any number you multiply by 1, you're going to get back the same number. We don't want that. So I'm going to go by 2. Okay, it gives me 0.125. Multiply that by 2. Gives me k 2 and 2. So my constant number is 2, and my sign is multiplication. So if I multiply this by 2, I get the next value of y. Get the next value of y, get the next value of y. So if I know that my constant number is 2, I know my next value would be 4. Good. So I know it's not linear because it's not addition. I know it's multiplication, so it's exponential. So this is an exponential function. All right. So pat yourself on your shoulder. You got through functions. So last week we did functions through graph. This week we did functions through either seeing it in an equation form or you see it in a table form. All right. This is the end of functions. If you need to get some more practice, definitely try to find some more Regents questions. Practice those. If you want me to go over them, I definitely can. Just comment down below and I will definitely go over questions for you. Our next video that is coming up will be system of equations. Some people find it a little bit easier, some find it a little bit challenging, but I will definitely try my best to make it as simple as possible. I will see you guys in the next video. Thank you for watching. Don't forget to hit subscribe and turn on your notification bell so whenever I upload, you will be prompted. See you in my next video. Bye.